H plus equilibrium equals to A minus equilibrium, and it's equal to the HA dissociated. Can you understand that bit? Okay? The H at equilibrium, which is much smaller than the HA initial. Okay? So you can take the H plus equilibrium. So you can take basically the HA at equilibrium to be almost the same. Okay? So alpha is defined as whatever dissociated over whatever was not dissociated. That means the initial. Okay, so these numbers are actually very small. That's one thing I want to stress to you. The numbers are very small. Okay? They are not, let's say, I would be very surprised if the number is like the fraction, like half or even 1 over 10. It's more likely to be like 1 over 1,000 or even smaller than that. Okay? Okay, so anyway, you don't actually need to learn how to derive this. All you need to know is this equilibrium. Okay? Amount of molecules which ionize and equilibrium over amount of molecules present initially. For those of you who are worried about the mathematics, in general, Cambridge is not fond of asking mathematical questions. You all catch the key phrase I said just now. I said Cambridge is not fond now. I make no promises about other schools. Okay, so if you want to compare the strength of acid, the solutions need to be at the same temperature and the same concentration. Okay? Because if not, you shouldn't be comparing them because the value changes depending on temperature and concentration. Okay, the other way it may be also expressed as a percentage. The greater the value, the stronger the acid or base. Okay, strong acid, that means it's 100% ionization. It will be alpha is 1. For weak acid, it's between 0 and 1. Okay, the fraction. Okay, alpha is dependent on concentration of the acid and base. Okay, so take a look at this if you want to understand why it's dependent on the concentration. Because it's an equilibrium. Okay, focus here on the water. Alright? If you have remember what I said about the weak acid not being dissociated. Most of it is not being dissociated. So if you take the solution of weak acid, you add in water. It will cause the position of the equilibrium to shift towards the right. Okay? In that process, the HA will dissociate to form H3O plus and A minus. Okay? So, it's even for the same acid, the degree of dissociation, let's say I take ethanoic acid 0.1 mole per dm cube. Yeah. Then I said, okay, it is maybe I can get a solution of ethanoic acid 10 mole per dm cube. So alpha for the dilute solution is going to be higher than that for the concentrated solution. Okay? Okay? Okay, people, stuff like this, don't panic. You get in exam, look at it, remember from the first, the basic principles, go and reason it out. Okay, reason it out, because this is simple enough for you to reason out. Reason out from the things that you learn for chemical equilibrium. You still apply, it still works. Okay, I don't want you memorizing this stuff. Okay, I want you to understand and then you can apply. Okay, so alpha increases with decreasing concentration. Whether acid or base. Okay, so let's go on to something you are should be more familiar with, pH and now pOH. Okay, so H plus is a measure of acidity. We talk about this. H plus doesn't exist as a free ion. Okay, so this I think okay, Nelson may be correct because over the past 30 years, I've heard many different names for it. Okay, so I would think I will go and check out for Nelson, but can we stick with this name as the most current one? Things change over the month. So Nelson, what is it? Okay, we're going to look at it. So now for the notes is hydronium or oxonium. Okay, maybe by the time some of you become chemistry teachers, you'll be something else again. Alright? Some of you sure become chemistry teachers. Cannot curse like us. May you come back as a teacher. Okay, so anyway, for simplicity's sake, we will use H plus. Okay, at university, this doesn't apply because they will insist that you use H3O plus, depending on the lecturer. Okay, so now, why did they do this? Because H plus concentration actually varies by a wide range, 10 to the power of 0, which is 1 mole per dm cube, to 10 to the power of minus 14, which is 1 mole per dm cube of OH minus. It's very wide. It's 14 orders of magnitude. Okay? So, they thought it was easier to make it a log scale. Okay, so pH is the negative log of the H plus, and H plus equals to 10 to the power of minus pH. I think that making this log scale for you guys at least is a mistake, judging from marking the paper. But nonetheless, you have to learn it. Okay? So pOH is negative log of OH minus. Okay? Concentration of the OH minus is 10 to the power of minus pOH. Okay? By the way, definition of pH is not in words. It's just that pH is negative log concentration of H plus. pOH is negative log concentration of OH minus. Don't write me a sentence in words. I don't want to see it. I just want to see this expression. Okay? So that's Cambridge. Okay, so this is the range. That one is just a pretty picture for you to look at. Okay, I remember as a student, I took some time and thinking about this, and I hope you also will do the same, because if not, you will get into trouble and writing out explanations. Low H plus means high pH. High H plus means low pH. Okay? Okay. If two acids or two bases at the same concentration, you can use the pH as an indicator of the relative acid or base strength. Okay? So, at equilibrium, okay, the H plus equilibrium should be how much dissociated. Lower pH means higher H plus, so means more acid. Dissociated means longer acid. Okay, this is actually a way, if you think of it, there are some questions that will ask you to predict whether something is a weak acid or strong acid. The way that you do it is you see, you check whether the H plus concentration is equal to the concentration of the acid. If it is, it's a strong acid. If it's not, it's a weak acid. Okay? Done? Okay, let's do example one by one. You all want to do this? I think you should. Please do it so that you restore my confidence in your ability to do calculations. Okay, can get 0.699. Okay. Okay. Now, let's look at the next one. Electrical. Okay, this to me is interesting because it actually has some application. Okay, electrical conductivity of water, even in the purest form, never falls exactly to 0. Okay, so because at neutral, pH 7, the concentration of H3O plus is equal to OH minus. Okay, so there's still some ionization. Okay? So, water will ionize and two water will combine, and then there's an equilibrium with H3O plus and OH minus. Okay, the simplified equation is this. Alright? Okay, so let's take a look at how it works out. Now, this one you need to pay a little bit of attention to it. Okay, the oxygen is the red circle. The hydrogen is the white one. Okay, so they all have one red circle, but the OH, right, there's only one white there. You can see now at the top there. The top, right at the top, there's a OH. Next to it is a H3O plus. And at the rightmost corner, you see that one that looks a bit like Mickey Mouse is water itself. Okay? Okay.
Ionization is the process in which two like molecules react to give ions. Water undergoes a self-ionization to form hydronium ions and hydroxide ions. The reaction maintains a steady concentration of each of these ions at 1 × 10 to the -7th molar under neutral conditions. The product of these concentrations is the ion product constant for water, Kw, and is equal to 1 × 10 to the -14th at 25 degrees Celsius.
Okay? Anyway, I left the YouTube link there in case you want to go and watch it. Now, can I issue a slide warning? When I was searching for this, right, online, I came across a lot of rubbish. Really a lot. There's somebody saying something about alkaline water. Okay, please don't go click on those because I think it's some scam. Okay. Okay, anyway, just to talk about this electrical conductivity of water. In some cases now, when they want to check whether, like you get deionized water, right? You have some electrical conductivity. For some industries, they require ultra pure water, very, very pure water. And the way they actually assess the purity of this water is to go and measure the conductivity of the water to make sure there are no other ions or other things in there. Okay? Okay, so let's look at what we call the ionic product of water, Kw. Okay? So if you have an equilibrium, water to give you H plus plus OH minus, okay, you can get Kc. When you rearrange, you can get Kc prime times concentrated water goes to a Kc times H plus times OH minus. So the degree of ionization is very small, so essentially the concentration of water remains essentially constant. Therefore, Kc prime times water is a constant. Okay? So they give this a special name. They call this Kw, which is the concentration of H plus and the concentration of OH minus. Okay? This is an important thing for you to remember. So, this, if I'm not mistaken, is in your data booklet. It's called the ionic product of water. Okay. Auto-ionization occurs in all aqueous solution. In any solution, Kw is a constant at a constant temperature. Take note, the temperature must be constant. Okay, so mathematically, it's this. If H plus increases, OH minus must decrease. Okay? because their product is a constant. So if you put acid into water, H plus becomes larger, position of equilibrium shifts to the left. Okay? And maybe some of the H plus will combine with the OH minus. But this decreases, causes the concentration of OH minus to decrease. Okay, so if you calculate the value for the expression H plus and OH minus over the concentration, actually 1.8 and 10 to the power minus 16. Okay, water has a density. 1 kg of water has a mass of 1000 grams. So concentration of water is actually 55.6. Okay, you can work it out. So Kw is actually 1 times 10 to the power minus 14. Again, you need to know how to derive this, but you need to know that the last one. Okay? Okay, I think it's time's up, so I'll stop here.